Okay, so good morning, everybody. I'm Val Wolf from the Occupational Health Clinics for Ontario Workers, and I really appreciate you joining us this morning for our inaugural virtual workshop on the new tool that John and others in the organization have iteratively developed over the past few weeks, trying to literally provide a tool that will help people in their workplaces targeted towards classrooms, but it does have relevance to other spaces where people gather. But the what it compares against is based on classroom regulations or guidance. So I'm just actually going to stop talking and turn it over to John, who's going to spend some time leading us through the tool in a bit more detail than we've been able to provide in just like a 20-minute infomercial about it, I guess, or the video that is posted online, which is about 10 minutes walking through it. He's going to help us all understand what each individual category means, where one can find it, and how changing it can make a difference to the other calculations, which is the whole point of using the tool, how we can improve air changes per hour in places where we gather. So over to you, John. Thanks.
Okay, thank you everyone for attending and for your interest. And this was a tool that came out of a bit of frustration. People were talking about ventilation, but they weren't telling us how much. So our goal today is that you'll be able to use this spreadsheet to measure the ventilation rate in your room. And as I said, adequate ventilation has been talked a lot about, but no one has given specifics on how to do it, and we hope this tool will fill the gap. So we'll be breaking in the session in three portions. The first, we'll go over the sections of the spreadsheet together. The second, we'll have breakout groups where you can ask specific questions about your situation. We encourage people to take the information from about their classroom, the size, things like that. So we hope that will help you fill in each of the input places. And then finally, we'll get back together and deal with any outstanding questions or comments or that type of thing. I must say this is a work in progress, so any suggestions you have on making it better are quite welcome. We have some facilitators for the workout groups. They include Dorothy Wigmore, Kevin Hedges, Masood Ahmed, Marie Lawrence, Valerie Wolf, and John Audick, myself. And they all have training in occupational hygiene. Hopefully they know some of the answers, but they may not know all of them, and that's why we're helping each other out. So why do we care about ventilation? Well, we're in the middle of a pandemic, and when this happens during a pandemic, it's of a concern. The green lines are the trajectories of large droplets which shoot out and then fall on the ground. These are pretty well large enough to see when you see somebody when they're talking and you see the particles fly out. Those are the big ones. But there's also the red cloud, the puff of aerosols that comes out, and they come out together. There's been some denial that the red cloud exists, but it does exist, and it's not heavy enough to fall to the ground right away, and it gets picked up by the air currents in the room and spread around. And so ventilating will keep the concentration of that red cloud diluted. We already knew indoor air quality was important in schools before the pandemic. There have been quite a few publications about the effect of low ventilation rates on the cognitive function among students. And so this is not something new, but the pandemic is kind of a learning moment, and hopefully the improvements that we learn now will benefit us in the future also once the pandemic has allowed us to go back to some semblance of normal, whenever that will be. Now, there's been studies on mask use and ventilation improvements in schools. And this one was published a few months ago. And basically what it found, that is, if you use masks alone, they provided a 37% reduction in infections. Ventilation alone gave a 39% reduction in infections. And if you use dilution, ventilation, and filtration, you got a 48% reduction in infections. And so this kind of makes you wonder why we're so adamant about policing masking, but we're not so adamant about policing ventilation. The Public Health Agency of Canada has recognized the need for improving ventilation. However, in their advice, it's basically left to the experts, an HVAC professional, to look at the system. Similarly, the Public Health Ontario guidance, again, mentions ASHRAE standards and CSA standards, but they basically leave it to professionals to be able to do this. And while professionals would be great to have, not every organization can contract them, and not every organization is able to know what the standards are saying. Also, even with the use of carbon dioxide measurements, again, they warn about people with no background on their use having trouble interpreting them. Even in the Ministry of Labor, they have their workplace plan building app online. And there is a mention of ventilation, but it's only at the very bottom of the workplace sanitation section. And it just says introduce more fresh air. It doesn't say how much at all. And it says avoid central recirculation where possible, which isn't a lot of help. So there are ventilation assessment criteria around. The pre-pandemic ASHRAE suggested 15 CFM of outdoor air per person, which is roughly 2 to 3 air changes per hour, or an equivalent of 1,100 parts per million of carbon dioxide. However, during the pandemic, they said you need more air than this. And so now their current recommendation, along with the ACGIH, is that you have at least 6 air changes per hour, and you want it somewhere in the range of 6 to 12, which would be equivalent to a carbon dioxide level of 700 parts per million or less. So the ASHRAE standard recommends in terms of air changes per hour. So we'll just go quickly over how to calculate air changes per hour. So here you have a classroom, 35 feet in length, 23 feet in width. And so the square footage is 805 square feet. And if we have 9-foot ceilings, we can calculate about 7,200 cubic feet in this room. We'll ignore the desks and the people. If we have 725 cubic feet per minute of air coming into this room from the ventilation system, then we can calculate the number of air changes by figuring out changing cubic feet per minute to cubic feet per hour, which is a huge number, 43,000. And then when you divide it by the volume, you get the number of air changes. So when you divide 43,000 by 7,000, you get roughly 6 air changes per hour. And you're assuming that mixing is perfect, which in a classroom is usually pretty good, but in some of the rooms may not be as well. However, not all the air coming in is outdoor air. So if the air is 80% recirculated and 20% outdoor air, you're really only getting 145 CFM of outdoor air in that 725 total. And so you're really only getting, instead of 6 air turnovers per hour, you're getting 1.2 air changes of outdoor air per hour. Okay, so we're going to go through this spreadsheet. It's designed as a tool to walk you through how to evaluate the ventilation in your room. And the idea is that you go through these sections about the type of ventilation, the room dimensions, the occupancy, the room ventilation rate, and we'll give you some ideas on how to quantify that. The filters, portable air cleaners, supplementary fan, and we take that all together and calculate the total number of equivalent air changes, clean air changes per hour. And there's also a spot that if you have a carbon dioxide measurement, you can type it in there. And when you're done, you can print this off and post it on your room so anybody coming into the room will know what kind of room, what kind of ventilation system the room they're entering has. So we'll start with the type of ventilation system and the room dimensions. Well, this is the easy part. To measure the dimensions of the room, you can use a tape measure, obviously, or count ceiling tiles or floor tiles or cement blocks if you can see them. There's also apps on some cell phones that let you measure them. I tried using it and I get a little confused, but people who are a little more adept at using these things probably can figure that out better than I can. You can also check the building layout plans or the fire exit posting if it's drawn to scale. You don't need to be exact. You're probably measuring to the nearest foot will do. The area and the room volume are automatically calculated, so you don't even have to do that. And you can enter the typical and the maximum room occupancy, and then you select which one of those you want to use for the calculations. But the first part is determining what type of ventilation system you have. And if you have ceiling diffusers that look like this, or at the top of the wall, a diffuser that looks like that, that's blowing air into the room, you probably have an HVAC, which stands for a heating, ventilation, air conditioning unit. If you have one of these on the right-hand side here, you probably have a unit ventilator. And if you have hot water registers or radiators or perimeter electric heating, then you probably have natural ventilation and you don't have air blowing in. If you have some times the plan of the building will have it. For instance, here I'm going to focus on our training room in our new clinic, and so here the dimensions are given 14 feet by 9 inches by 21 and 10 inches. And the occupancy we expect in that room when we have meetings would be anywhere from 10 to 20. So we put those things in, and then we find out that our meeting room has 322 square feet, and it gives a volume of almost 3,000 cubic feet. And there's a calculation done that I dropped the typical room capacity down to 6 in order to show you that 6-foot distancing is achievable if you have 6 people in the room, but it's not achievable if you have more. Then we have the room ventilation rate. And this gets a bit tougher. You'll probably have to ask someone for this information, maintenance, facilities person, maybe even a health and safety rep. It can often be found on building drawings, the ventilation plans, and this would be the design flow rate in cubic feet per minute. If you have a ventilation balancing report, you could use this. Even if it's old, as long as the system hasn't had much changes made to it, it should be relevant. If you're trying to figure out the proportion of the outdoor air supply, you'll probably have to ask about this. Sometimes it's fixed and sometimes it's variable. And if it's variable, you might have to figure out what the maximum and minimum percentages are. And again, you'll have to ask for it. So I've listed 7 ways here that you can figure out how much air is coming to your room. And the easiest one is obviously ask somebody who knows. The next one is looking at the ventilation drawings. And here's a sample ventilation drawing. And here's the room that we're interested. It has 3 diffusers in it. And the first number is the cubic feet per minute, the amount of air. And it's coming in through registers like these. And they're 10 inches by 4 inches. And that's what the 10 by 4 number is. And if I add these 3 together, I know that the room is getting 580 CFM. Now, on drawings, you can also have this type of symbol. Here we have, again, 135 and 75 CFM. But this symbol with the X, the box with the X, represents this type of diffuser, usually. And the 8 and a circle with a line through it means 8-inch diameter. The other one is a 6-inch diameter. So that's how you can get the CFM from ventilation drawings if you have them available to you. You can also, especially for unit ventilators, you can look at the plate that tells you the model and serial number of the unit. And here's an example. And this is a unit that's in our building. And when I looked it up on the internet for the maintenance manual, it didn't work if I put in the whole number, but if I put the first 4 numbers, it did work. And then I found the manual, and it's dated 1981. So our unit is about 40 years old. Normally, these things have a life expectancy of 15 to 20 years, so you can imagine how I feel about this. And in the manual, I found our model, and it has nominal cubic feet per minute of 3,000 CFM. And so that's another way of finding out. Have someone else measure it for you. If you have an air balancing report, this is an example of an air balancing report we had in our building done this summer. And you have all these tables, and at the right-hand side of the table, you see CFM. So here's all the measurements that were taken, and the room that I'm interested in is called storage room here, even though it's a training room. And you can see the numbers here, and they add up to 574 CFM. Now, sometimes you have to go to the back to see the drawing and figure out which ventilation system. We have 2 of them, and the numbering will be on this drawing. And this is the type of machine that the person who does the balancing use for the outlets in the wall. On the ceiling, he used this bolometer, which is kind of like we call it a pup tent, and you put it over and it measures the amount of air going through there. And here's another picture of a bolometer. And this on the left is a thermal anemometer, and it has a probe that measures the airflow, and you can stick it inside pipes or at the end of the bolometer. And here's our own homemade bolometer. We took a cardboard box and put it over the diffuser, and you can see Murray here putting the probe up into there. And we have 4 holes on the bottom, and we put tape on the probe so we know exactly where to place this, and then we take the average over the thing. But you probably don't have one of these machines, so what are you going to do? Well, here we have a nice little class project for your classroom. This is coming from a publication put out by Canada Mortgage and Housing Corporation, and it's how to measure the airflow on your registers in your home. And you see here, you tape a cardboard ring or a coat hanger around the opening of a garbage bag, and then you place it over the register, and you time to see how long it inflates. And some people have cell phones with timers on them, so also do it the modern way. So this is what we did. We tried it out and we filled it up and then collapsed it. And we tried to do it 3 times and time each one and then take the average of them, because it takes a little bit of practice in order to get coordinated between the two people and also to learn how to put it on right away. So if your 3 readings are within about 10 to 15% of each other, I would say then you've got it down. If they're much different than that, you might want to do a few more measurements until you can get the variation down a bit. But the plastic bag has a certain volume, and the way we did it is once it's filled up, we measured the length because it fills up pretty well like a cylinder. And then you do the math. Here again is a nice exercise for the students to calculate the volume of the cylinder. The circumference you can find out on the box of the bags, because it usually tells you how wide it is. So if you double it, that's the circumference. And then you just use your pi r squared and your height and calculate the volume. And if just to make sure you get the right answer, you're probably somewhere between 3 to 5 cubic feet in one of those bags. If you have a carbon dioxide meter, you can also measure the carbon dioxide and estimate what the airflow rate is. Now, it's best to measure it not first thing in the morning when people are just coming in, but just before lunch hour or at the end of the day when you get your peak CO2 readings. So you want to make sure your carbon dioxide meter is reliable, so you want to check with the manual. It may give you some ideas on how to calibrate it. If you want to check, what I did is I took a clear plastic bag and put the went outside, filled it up with outdoor air and put the unit inside, and then tied it off and brought it inside, let it warm up, and then your outdoor CO2 level should be somewhere between 400 and 450 parts per million. It may be higher if you have a busy highway beside you or something like that. Now, ASHRAE has an equation that lets you figure out how much air is coming into a room based on the occupancy, the percentage outdoor air, and the peak CO2 concentration. Now, outdoor air intakes are usually somewhere between 10 to 30%. If you don't know, you can just take 20% or do it 3 times, 10, 20, and 30%, just see how it varies. So this is a little calculator that allows you to figure this out. And so let's say your classroom CO2 peak concentration is 2,700, which is not unusual in naturally ventilated classrooms. And then you can see, you can change the occupancy and things like that and figure that out. So another way, which is a bigger math project, probably for high school math, is to calculate it from the decay of the carbon dioxide measurements. So you have to have a meter that data logs, that stores the measurements over time. And if your HVAC is shared between other rooms, you need to wait till the end of the day, till people leave the building before you use that data, because you know, if your classroom is empty but the other classrooms sharing the ventilation system are full, obviously some of that carbon dioxide is going to come into your room, and that's not going to be a true decay curve. But waiting till the end of the day, you have to make sure that that the HVAC is still on when the decay happens. So the equation calculates the outdoor air exchange rate, not the total ventilation rate. So you need to back calculate the total ventilation rate based on the percentage of outdoor air. And in a room with 2,900 cubic feet and a measured 3.2 outdoor air changes with 20% outdoor air, you can figure out what it is and convert it from hours to minutes, and then it's 700 CFM of total airflow rate. Here's an example of a decay curve. At 5:45, it was 850 parts per million, and at midnight, it was 560, and that took 6.2 hours. And you put it into this equation, and you can figure out it's 0.2 air changes per hour, which probably means that the ventilation system shut off rather than was running when this happened. A ventilation system should do, if it meets ASHRAE standards, about 2 to 3 air changes per hour. A tight building with the doors closed and everything sealed up is about 0.2 air changes per hour. And last of all, if you can't do any of these, there's some rules of thumb that you could use. The first one is multiply the area of your room by 1 CFM per square foot. So if you have an 800 square foot classroom, it's very easy to multiply, and you get 800 CFM. There's also another design rule of thumb that suggests you should provide 5 to 6 air turnovers per hour. So again, you have to figure that out. 800 square feet classroom with 10-foot ceilings has 8,000 cubic feet, and 5 to 6 air changes per hour would be anywhere from 667 to 800 CFM. Okay, now we have the filters. This should be fairly straightforward. You can ask anyone who purchased the filters for the organization what they are. Sometimes this is a contractor, so you may have to talk to the contractor, the maintenance facility person, maybe the health and safety rep knows. They may not give you a Merv value. There are other ways of classifying filters, so I do have a slide coming up that allows you to convert from one system to another. But if you feel adventurous, ask to have a look inside the unit, and then you can see the filters and take the numbers off the side, but you can also see how snugly those filters fit. You know, you can have the best filters, but if the air finds a way around the filter because it's not tight, it won't be as good. Take some pictures. Remember that all the air you breathe has to go through this unit, and so if you see something ugly, it might be wise to take a picture to show that something needs to be done. So a Merv 8 is the type of filter that people used prior to the pandemic, and that gives some equivalent air changes per hour, but not a lot. We also put in a box here where you can write in the date the filter was last changed. And even if you can't remember, if that's posted on your door, and it's probably be embarrassing to somebody, so they'll find out exactly when the filter was changed. So if you have a look inside, this is a picture of a filter that's the filter on the left-hand side here is actually bent, and the air is going around it, but you also see evidence of moisture. You see a lot of dirt and rust and things like that. You know, this is what the air you breathe has to pass over before it gets to you, and so it's probably wise to listen to your gut feelings about how you feel about this. Here's the slide that converts from between the different systems. There's the FPR system, there's the MPR system, and there's also a TO system, and it roughly tells you which ones. I also thought it might be helpful to look at the Merv ratings and compare them to the different types of masks people are using. For instance, a gator mask is somewhere between a MERV 1 and 4, which doesn't do much. It stops butterflies and dandelion seeds, but it really doesn't do much for the small particles. Cloth mask is a little bit better, but not much. Surgical mask is about a MERV 8 to 10. And remember, MERV 8 is what we were using before the pandemic. An N95 respirator is about a MERV 13 to 15. And an N99 respirator is about equivalent to a HEPA filter. Now, if you have an N95 with an exhalation valve in it, when you're inhaling, you're getting the benefit of an N95 respirator, but when you're exhaling, it's equivalent to a surgical mask. And I'd remind you that a surgical mask is equivalent to just putting the hand over your mouth. It doesn't do a whole lot. And by the way, the Public Health Agency of Canada has changed their advice on COVID mask use. They now recommend that a respirator is allowed to be worn, allowed in quotation marks, and you don't have to have a formal fit test in order to use it in the community. And I hope this will alleviate some of the grief that we've had in some of the school boards. Okay, so here we have the air changes per hour again, and we're going to put a MERV 8 filter and see what that does. So without any filter, we had 1.2 outdoor air changes at 20% outdoor air. But when we put a MERV 8 filter, that's equivalent to another air change per hour. So now we have 2.2 air changes, equivalent air changes per hour. Now, if we change this to a MERV 13 filter, we actually get much better filtering. And that's equivalent to 4.3 air changes per hour. And when we combine it with the actual outdoor air, we get 5.5 equivalent air changes per hour. So you can see that a MERV 13 makes quite a difference. Then we have the supplementary portable air filters. So this gets a bit complicated, and it's really consumer beware. You have to find the CADR numbers, CADR numbers, and sometimes they don't give those numbers. If it's a HEPA system, then the CADR number is about the same as the airflow, the airflow rate, the CFM. But I have seen one of the portable air cleaners that are used in classrooms that calculated the CFM without the filter in it. And in the small print, it said it was rated at 400 CFM, but it was actually only about 275 CFM once you put the filter in. So again, consumer beware. There are different speeds which relate to different airflow rates and different noise levels. The noise level is important because if it's too loud, the CADR rating is for the top speed, and if you're not using the top speed, you're not getting that level of cleaning. And don't go for the extras. You don't need ions, you don't need UV. I even saw one system that had vitamin C being emitted into the exhaust stream. So here's the one we use in our clinic. So when I went on the website, it actually gave me the CADR numbers for pollen, dust, and smoke. They're all the same, so it didn't matter which one you use, but smoke might be the good one to use if they're different. It also gave the sound level. It has 3 speeds, so I only know what the sound level is for the low speed and for the high speed. Now, there's a website called Verifidi, AHAM, and on it you can see all the certified air cleaners. And so when I looked up the one that we have, it popped up this item that tells me the CADR for this, but it doesn't give any other information about the noise. The 540 square feet is at high speed. If you're not using it at high speed, it's not 540 square feet. Some of the units also have Energy Star rating, and if you go there, you can find your product on there, and it gives a bit more information. It gives the CADR numbers, and it gives them more exactly, not rounded off. Oops, previous, and no, it didn't give the noise levels. And then I also went on the Amazon site, and on the Amazon site, you can find the user manual, and that's kind of helpful. So this is the user manual for the unit, and you get even more information here. You have the noise level and the CADR, but you also have the airflow rate for the top speed and the lowest speed. So now we can put some of those numbers in here, and the spreadsheet is built in such a way that the numbers will change colors depending on the decibel level. If you're below 40 decibels, it's green. If you're between 40 and 55 decibels, it's yellow. And if you're above 55 decibels, it's red. And this is based on ASHRAE recommendations of background noise. Yellow may be tolerable, but if you're doing a test, you don't want a lot of this noise distracting people, or if you're talking, interfering with speech. So you can also change the number of units so you can see at what level you want to run these. If I run them at the slower speed, I get obviously less cleaning, and I may need more units. Supplementary fans. If fans are simply circulating the air, they won't contribute to bringing in outdoor air. In fact, they may blow one person's emissions towards another person, which is not a good thing to do. So what you want to do is, if you're using a fan to bring in outdoor air, you don't want to put it in the window and blow it in. You actually want to turn it around and blow the air out and open another window so it seeps in at a slower speed, so it doesn't blow emissions from one person to another. So it may be difficult to find the airflow rate from the manufacturer's information. You can check the technical details or the manual, but generally, as a rule of thumb, if you have a box fan, 20-inch box fan, it's around 1,000 to 2,000 CFM. 12-inch is about 600 to 1,200 CFM, and then 6-inch or 6 inches about 250 to 450. So then you can enter that information here, and if you're just recirculating indoor air, you won't get any equivalent air, outdoor air. But if you're bringing in outdoor air and the percentage of the time that the fan is operating, that helps. So here we have the sheet filled out, and because of the room capacity, we can figure out whether or not distancing is achievable. We know the total outdoor air changes from the ventilation system, and we know whether or not it meets ASHRAE 62.1. We have the filters here and what the equivalent air changes that the filters provide, and we also have the date, or don't know the date when the filter was last changed. We know about the ASHRAE noise recommendations on the portable air filter and how many air changes that provides. And then we also have the supplementary fan. And then when we add them all together, we get the total equivalent clean air changes per hour. And for this one, it's 14. And below here, you see the criteria. You want to be more than 6 to 12, and yes, we are above that. And then if you're less than that, you can, it will change colors. And if you put your carbon dioxide peak measurement in here, it will also grade it according to this standard here. So what we can do is post it on the door, and then when someone enters the room, they know exactly what they're getting into. So that is it for the presentation. And what we will do next is go to the breakout groups. But if there are any pressing questions that aren't specific to your classroom that we can deal with in the breakout, we could do them together.
So there are a few questions that were posted in the chat that I think it's worth maybe trying to touch base on before we divide up.
Okay.
David asks, and I'm sorry, I'm smiling. It's not that it's what we all want. He's a Joint Health and Safety Committee member and is wondering, you know, he continually asks for ventilation information in the schools and never gets a straight answer. We're familiar with that happening not just in schools, in many buildings. I would like to know what is the simplest way to calculate whether or not classrooms have adequate ventilation. During safety audits, it would be beneficial for me as an auditor to take a few measurements to figure out whether ventilation is adequate or inadequate, I guess. That's a tricky question. Any ideas?
Okay. Well, I gave 7 different ways of doing it. Probably if you're on a safety tour, if you have a carbon dioxide indicator and you're long enough in the room for it to equilibrate with that room, that might be the quickest way. And instead of using air changes per hour, use the system that we provided for CO2 concentrations, about whether or not it indicates enough air being provided.
Great. And actually, there was another question related to that, and then I'll go back to the next in line. But I think someone asked about, maybe I'm misunderstanding. Kevin, you answered a question? Is there a difference? Is there a difference in airflow in an unoccupied room versus one that has many occupants? And then the question was, why would you measure at the end of the day when the room is unoccupied? When you were showing the decay curve, you talked about that.
Yeah, the carbon dioxide, it makes a difference. It doesn't make a difference for if you're measuring airflow. If you're using a plastic bag, whether people are in it or not, it makes no difference. However, the carbon dioxide, because it's an indicator of how much outdoor air is being brought in, the more people in the room who are the source of the carbon dioxide, the more the higher the concentration of that. If you're interested in the carbon dioxide as an indicator of ventilation, this afternoon we have a webinar where Kevin Hedges will discuss that. So join us this afternoon if you want a little more on that.
Yeah, I was just going to say the same thing, that we're going to try and cover more of its use as a tool and its, also how to be guarded about it as well. So, but it is a very functional tool if you're lucky enough to have a monitor. And also a question around can adding filters above MERV 8 to the air handling unit increase the load on the unit and maybe require then frequent maintenance or additional maintenance?
Yes. If you're the person specifying what level of filtering, you need to take into consideration what your HVAC can handle. I've seen some work suggesting that the difference between a MERV 8 and a MERV 13 is not that great, and that most systems should be able to manage the back pressure, the increase in back pressure. It may cut your volume slightly, but if you try to put a HEPA filter, which is MERV 18, 20 or more on a system, you'll severely drop the amount of air that's being circulated, and you'll put burden on the fan and the motor. And if you're not careful, you may damage your ventilation system. So before you change the filters, it's obviously wise to talk to somebody who knows the mechanicals of the system and can tell you whether or not it's possible.
We should try and find that. Jim Rosenthal had slides on that in his presentation.
Yeah, that's where I got it from. That's what I was referring
that was in
to.
September. So I will go look for the link to that. There's a
Yeah,
video.
I think he said a Merv 8 was 0.2 inches of water back pressure, and a Merv 13 was, I think, 0.26 inches of water. So it's not, it's some, but it's not that much. And he, in his presentation, he suggested that most systems should be able to handle an increase in back pressure like that. Dirty filters will probably also increase the back pressure, and it may be equivalent to 0.06 inches of water.
Yeah. He also showed the iterative processing of air. Well, that's with the Corsi-Rosenthal box, but the iterative that captures a lot of particles of this size, right? Well, I know it's a range of sizes, but Merv 13 is a significant improvement over Merv 8. I think is the point that can be done mechanically safely. There's a question about mentioning that ASHRAE has changed its recommendations since the start of the pandemic, but Public Health Ontario doesn't seem to have. Or has that been updated as well? I honestly have not checked PHO lately, but
okay, PHO and the Public Health Agency of Canada both refer to ASHRAE. So as ASHRAE changes, theoretically their recommendation changes. So they get off the hook there. But ASHRAE has been up and down and all over. At first, they were saying as 100% outdoor air. And, you know, we were in the spring at the time, and so it was possible. However, when it got hot in the summer, they changed it to as much as you can. And if you can't do enough, then use supplementary air cleaners. Then they went to 6 to 12 air changes per hour at least. And then they cut that back and said you can save energy by not bringing in as much outdoor air as long as you clean the air. So increase your filtering. And now a few weeks ago, they went back to 6 to 12 outdoor air changes per hour. So they've been a bit up and down like a yo-yo, but I checked the latest one, and I think I've got the latest one in this spreadsheet now.
There's one more comment about the difference between, we are measuring CO2, which is a gas, and then we're talking about supplementary air filtration of the particles, not just supplementary, the system filtration, and then the supplementary if we're using an air cleaner. Just reconciling that because yes, indeed, as they point out, the air cleaner will not remove CO2 from the air. But
no, CO2 is a gas, and we're not worried about CO2 as a toxic effect on people. CO2 is just an indicator of how well you're diluting what people exhale. And so it's just a marker substance. If you had a CO2 filter, then it would ruin your ability to calculate the airflow rates. So no, the filters, the portable filters have nothing to do with the CO2 level. In matter of fact, as I was mentioning, when ASHRAE was trying to cut back on the amount of outdoor air being supplied and using filtering instead, they were actually allowing the carbon dioxide levels to go up. Now, the carbon dioxide levels are not only an indicator of ventilation for the purposes of COVID, they are also an indicator of ventilation for the purposes of indoor air quality, which I showed in that article is related to the performance of students in their schoolwork. So it's a bit broader. The carbon dioxide issue is a bit broader. And the Harvard people, School of Health, who have been also recommending standards, they've suggested that there's a hierarchy in how you should control the ventilation, and that number one is bringing more fresh air in. Number two is increasing the filter in your HVAC system up to at least a MERV 13. And number three is using air cleaners if you can't achieve an adequate equivalent clean air supply using the other two methods. So they set it up as a hierarchy. But however, ASHRAE, a few months ago when they were dilly-dallying, they turned that hierarchy upside down in order to save money on energy. Well, and also greenhouse gases and climate warming and et cetera, et cetera.
Mhm. Okay, thanks. And then we can have more discussion on that this afternoon. I know David Elstrom who's also speaking this afternoon on ventilation and air cleaning, had a rule of thumb on Twitter that if you've got an air cleaner running, that you can tolerate a slightly bit more carbon dioxide. So if we say 800 is an indicator of a problem, is 1,000 okay? But that's from a COVID
I
perspective.
disagree with that because,
Yeah,
as I said, carbon dioxide also affects the performance of
I agree.
carbon dioxide itself, but all the pollutants that build up with the carbon dioxide affect the performance of kids in schools. So I wouldn't give that latitude on the CO2 myself.
And it's still an indicator of other problems, even if you filtered out the particulate, as you say. So there's one more comment in terms of what about if they fix the air quality before testing, so you don't know what it was like prior. That is a common problem in health and safety, that if they know an inspector or a testing is happening, things get cleaned up and smartened up. But if that cleanup continues, that still had a beneficial effect. It's right. So, but it.
Well, they probably can't change the airflow that much unless there's a major mechanical change to the ventilation system. They can change the percentage of outdoor air being brought in. So if you had high carbon dioxide levels, if you're using that to evaluate your ventilation, and then all of a sudden they drop, then somebody must have made a change in the amount of outdoor air being supplied.
Mm-hmm.
And that, like you say, that's a good change. So you can at least be satisfied that it was. If you collect evidence for inadequate ventilation prior to, I'm not sure what you can do with it, because the Ministry of Labor doesn't retroactively penalize people for violations that have been fixed. So, if you're trying to determine why someone got sick or infected or something like that, that may be useful information, and that would interfere with the forensic investigation. But going forward, it's a positive.
And there are possibilities in some, like in sophisticated buildings, that there would be record, like the computer would actually have a record. If you, as a Joint Health and Safety Committee, can request that information of the last X months of, there's often CO2 monitors in the system, because the variable air volume ventilation systems work on that. Sometimes they're triggered to open the dampers if the CO2 levels get to a certain point. So there may be archived information in the ventilation system if it's run by a computer. So that's another possibility. I imagine not too many schools, but certainly in a university they would have that.
Well, new systems often do have computer controls. So
Yep.
if it's a very new, however, in our building, our system is 40 years old.
At least we don't. That's just the one unit. We don't know how old the bigger units are, but we're in the process, at least, of the landlord is listening and getting them upgraded and replaced. So, but that is actually related to this, a struggle for even us to figure out what it is we want to ask for to have sufficient ventilation in the various parts of the space. So I think it's time to move to the smaller group discussions. So we do have 6 facilitators, and we will move into the breakout rooms randomly. And we do have the ability to move people if someone thinks they need to be beside their colleague, but generally we hope that the ability to talk in small groups, and even if people have any sort of numbers or approximate numbers, we can work our way through through the tool using people's examples, and then we'll reconvene here. We'll give probably we'll do this for about 20 minutes or a little bit longer, and we'll reconvene here to learn what we learned from each other, and any questions that anyone has after that. So, John, did you have anything else you wanted to mention with respect to?
Nope.
And yes, oh, wait, one more second before, sorry, I can see the texts from Tony in my upper right-hand screen. Just when we go to breakouts, there is actually a requirement that you have to join the breakout you've been sent to. So if you're not sitting at your computer and you're watching from across the room or whatever, you won't be in a breakout room until you actually click to join the one you've been assigned to. Go ahead, John.
No, I didn't have anything to say except that on my computer, at least, it's in the top right-hand corner and it's not that obvious what the button is to join your group. Yeah,
it's where the notice comes. Depends on how you depends on the type of computer and how you have your layout chosen, I think. So, okay, Tony, I'll ask you to do the start the breakout sessions, and we'll see everybody in there, and hopefully we'll be able to use our videos. Oh, I guess just to clarify from a facilitator perspective, so we have the 7th version, or should we use the 6th from the website right now? And then I guess there's going to be a 7.
They're roughly equivalent.
Okay, and the one that we will post next week, which I did put in the chat, the one that has the supplementary sheet on the back of it, so that that has some of the information from the slides, essentially.
Yep.
Okay, great. Thanks. Okay, Tony, let's go meet in smaller groups, and we'll see everyone in the big group again in 20 minutes or half an hour. Thanks.
Welcome back, everyone.
So, so we had a good dialogue, I think, in our group, but we didn't, because this is an experiential workshop. It's not like go away and come back and present your findings. But does anybody have any comments, I guess, from the participants or from the facilitators about things they learned, or questions for John, I guess, to further fine-tune the use of the tool and its application? Yep, Dorothy? Oh, go ahead. Well, Masood,
yeah, we have 2-3 questions.
Okay, great.
Okay.
And then Dorothy, we'll go to you next. Okay, Masood.
So the question was around room ventilation. So what if there is no mechanical ventilation or no natural ventilation in the classroom, or if there's a mechanical ventilation but not working at all? What was wondered was, can we enter 0? Of course, it's not going to work, but it works at a certain threshold from 20 CFM and up. I guess it's because of how the units are designed to achieve minimum air changes. But I'll let John to answer this question. And the other question then is about Merv. So if John, if you want to address,
Yeah, in our group too, it was noticed, and I tried to use the natural ventilation section, and it didn't work properly. So the way to do natural ventilation is to leave it on HVAC, but change the percentage outdoor air to 100%, and then estimate what amount of air will be infiltrating just through the building. No building is perfectly airtight. I think I showed you on the CO2 decay curve an air change of 0.2 air changes per hour. That's when the ventilation system is shut down and all the doors are closed and the windows are closed overnight. So there is a minimum amount of air that does seep in through the bricks, through the cracks, through the windows, et cetera, through the walls even. And so if you multiply 0.2 air changes per hour times the size of your room, you'll get the amount of cubic feet that are changing in the room per hour. If you divide it by 60, you'll end up with the CFM. And that's what you could put in the HVAC design box.
So 0.2 is the air changes you'll have anyways, right?
Sorry?
So 0.2 air changes is the air changes you'll have if there is no
It's like passive.
Yes, yeah, that's probably the bare minimum.
Okay.
A normal house has about 0.4 air changes per hour, a residential house. By the way, if you measure the carbon dioxide in your residential house, you'll probably find very high levels.
And then there was other question about Merv ratings.
Yeah.
Why we are not able to enter no Merv rating, like 0 in the box.
Well,
because,
I restricted it from 1 to 20 or 30 or something like that. There's a restriction on it. If you want no filter, if you put Merv 1 in, that's equivalent to no filter. I think no filter, you don't really get any benefit until you get a Merv 5 or 6. I can't remember.
Yeah. John, what if there is Merv 8 plus, let's say Merv 13 in place, but it's not intact? What if it's punctured or collapsed, or in that case?
And you got 0.
You just put 0, or?
No, there probably would be some. I would probably put it back to Merv 8 if it was. It depends how big the damage is. You know, if one whole filter is missing, well, then you may want to put it down to Merv 1 or 2. But yeah, Jeffrey Siegel, he's the filtration expert, and he's published a number of papers that showed what the usual leakage rate in residential homes with filters was. And if we wanted to, we could provide some advice based on one of his papers, but I think, I'm not going to try to remember what the numbers were, but
okay.
It's not 100% anyway.
It's the difference between a surgical mask and a respirator, essentially, right?
Yeah.
It's sealed, fitted, and goes through
Yeah.
the filter or goes around it. Sorry, Masood, go ahead.
Okay. So then Linda Rowley has a question and comments about some inequalities observed during this pandemic, and she's trying to, find out how we can, solve this issue. And so, Linda, you want to go ahead and ask yourself?
Yes. So my concern was with the poor and disadvantaged schools, rural schools that wouldn't have resources to do any of the studies. And I question, not only bringing in consultants, but also question about the safety committee, which might be like a professor and maybe an HVAC guy that is basically a handyman that changes a filter every once in a while, maybe once a year. And if the insurance companies or workers' comp companies would be able to assist with those resources, do they have the expertise, equipment, and some knowledge to come and try to use one of these spreadsheets to help figure out what the needs are before just going down to Home Depot and buying the air cleaner units?
Well, this spreadsheet was designed with the occupant of the classroom, the teacher or the helpers in mind, that they could take these measurements themselves. So you don't need any expertise to fill out these numbers. One of the most difficult numbers to figure out is the airflow, and we gave you 7 different ways of doing it. And even if you use the rule of thumb, you know, anybody can multiply the number of square feet by 1 CFM per square foot and estimate what the airflow is. It might be better than nothing. If you have no airflow, then that's what I was just talking about with Masood. You can probably enter a number of 0.2 air changes per hour, whatever that works out to be for the size of your room. So a lot of this was designed not for health and safety committees and not for inspectors or for ventilation maintenance people. It was meant for the occupant to actually fill it out and print it off and post it on their door. Now, to solve the problems, finding out which air filter you need or portable air cleaner you need for your room and things like that, you can fool around with the spreadsheet and change, you know, if I put 2 air cleaners in, what does it do? Or if I change my filter from a Merv 8 to a Merv 11, or from a Merv 11 to a Merv 13, what will that do? So by playing around with it, with the numbers, you can kind of figure out what is the easiest or the best way of increasing the equivalent clean air changes. So it was designed that anybody could use it.
Thanks. Is that it, Masood? Because I know Dorothy has some as well. Thanks, Linda, for your comments. Sorry, I shouldn't have skipped over that. So thanks for and yeah, it is true that rural organizations have a challenge, but yes, that's what we're trying to do with our knowledge translation, and the tool especially is empower people to be able to at least do some of the basic calculations and see the difference that different solutions make. So if you put in 2 air cleaners instead of 1, what does that do to your relative equivalent air changes per hour? And the leap between MERV 8 and MERV 13, of course, is significant, but it only is a value in a place where there's an HVAC system, and a lot of schools wouldn't have that. Although I'm not sure if you were from the US, I know there are also schools that are like centrally located that all the buses come to that are more modern, that might have HVAC systems. So, okay, we'll go to Dorothy, and then I see Ian has his hand up. Unless Masood, I'm sorry, you're done, right?
Yeah, no more questions.
Okay, Dorothy.
Can I share the screen? Is that going to work?
I think so.
Okay. Let me just do this because so in the group that I was in, we were looking at a classroom. This is one that David had looked at, where there essentially wasn't anything except one air filtering unit. So it was natural ventilation. We actually had the dimensions. We knew the number of people in the room. And when I tried to enter 0 in the Merv rating because there wasn't a ventilation system, that didn't work. But somebody in the group pointed out if you just left it at 8, we got a result. Because what happened was if we didn't
right, because it wasn't in there, no HVAC. Mm-hmm.
Then if we put nothing in, we didn't get a result. But if we just sort of left the MERV there at something, and we had this information about the portable air filters, we got this 2.6. And what we discovered was that if we went to 3, we actually got better air changes an hour, certainly in the better range. And the other thing that we learned was that the 6-foot distancing wasn't achievable in this space. And so even with, we still have some issues, but we at least know that in this case, that if they put 3 units in, that they're going to be better off in terms of the air in the room. There are other criteria that people asked about, sort of, well, would this sort of distancing lead to issues around wearing masks or respirators. But this was an example, John, of just sort of playing with that, you know, the sheet and discovering that it doesn't much matter what you put in if you say there's no HVAC system, you just have to have some number in for the filters. And then if you've got air filtering portable units, then you can actually sort of play with this. And you don't even have to know. This was a situation where there's no CO2 information available.
This is a work in progress, and in our group too, I tried to do something similar with natural ventilation and it didn't work, but I did figure out a workaround in the meantime until I fix this problem. If you go to the top and you put yes into the constant flow.
Where are we looking at?
Left, top left.
HVAC constant
Okay,
flow,
sorry.
put
Yep.
yes there,
Okay.
and then take out the one from there. And then in HVAC design flow rate, remember what I talked about with Masood? You have a very small classroom, 575 square feet. And if we work that out, natural ventilation at 0.2 air changes per hour will probably give you, let's say, 100 CFM.
Okay, is that design flow or yeah?
Design, put it in design because
Okay,
the method
yep.
doesn't work. And then put proportion of outdoor air 100% because it will all be 100.
Okay.
Okay, so that's what your air turnovers will be, which is actually a little high. Maybe if you put the
You want that to end at 0.2, so it would be 20?
yeah, well, put it to 50 and then see what that does.
50 here?
Yeah.
It'll go half.
Okay, 0.5. Yeah, I think that's probably appropriate for a school that's occupied.
You also didn't change the number of units because there's only one unit in that classroom.
Yeah, and so I'm just going to go down here and do that.
And now you're at 3.2.
So it's gone from 2.6 to 3.2, but it's still crappy.
Yeah. That's the workaround. If people come back to the website in the new year, I'll post a new one that updates and has those corrections.
Yeah. But what I
apologize.
liked about this, and I think others appreciated, was the fact that if we played with the number of units, we could see that there was possibilities for improvements there.
Improvements in air quality, however, increasing the number of units just increases the number of decibels, which becomes problematic now, right?
Yeah, John, I wasn't sure how to tell which on this tool, since you have it open, Dorothy, whether you're using the high or the low speed and to make it do the calculation.
Okay, there's
I'll go back there.
okay.
Okay, where would you like
And
me to
then
go?
I know Ian
No,
has
that's fine. If you go down underneath the 3 decibel readings, there's you can put in 1 equals max, 2 equals min, and 3 equals typical. So if you change that 3 to a 2,
yeah.
and then you'll see that your number of equivalent air changes have dropped, but your noise is now acceptable.
Right. And we did have comments from a few people in our group of units having been supplied by the ministry or by the school board as a result of the, you know, for instance, in the kindergarten classes where they were all mandated because of the inconsistent mask wearing, and that they're often turned off because of noise.
Yeah.
So Ian, you have a question, or Dorothy, was there something else?
Yeah, so David, any other questions from you? And then Daryl had a question as well.
No, that's great.
The only other parameter we tried to play with was occupancy, but noted that even if we reduced it by half, it had very little change in the outcome.
Well, for a room that small, if you go back there, Dorothy, if you change it to 2,
Change what to 2?
the typical room, yeah, that one. 15, if you change that to 2. Okay, and now bring it up. No, go back. Now bring it up 1 by 1. So change it from 2 to 3. And from 3 to 4.
Oops.
4 to 5. 6.
I'm going to 8.
7.
Yeah,
8.
you can go by 2s maybe.
Okay, 10.
We can,
So I think 11's, oops, in the wrong box here. Sorry.
yeah, I think we need to switch in here. Ian, can you ask the question maybe while Dorothy's trying to find us something that, well, yeah, you've got 6 feet. Oh, you're trying to make it not achievable now. But that is a small room. Was it an actual room?
Okay, there it is. Yeah, it's a very small room. So the 6 foot distancing is calculated by 6 foot radius around each occupant. And then I just calculate how many of those circles you can fit into that rectangle. Plus, I give the teacher 3 circles so that they have room to walk back and forth and talk.
It's 6 foot diameter with the person in the middle, isn't it, John? 6 foot area?
Yeah, 6 foot diameter with the person in the middle.
Yeah, because then they would be their 3 feet and the next person's 3 feet, right?
Yeah.
But I think the point that people were asking about here also was not just about the 6 foot distancing, but that it doesn't change the total air changes per hour. If you, and that's in terms of what's needed.
Well, if you think about it, the amount of air doesn't change with the number of people you put in there, but the distancing and whether or not you achieve the ASHRAE standard will.
Mm-hmm.
Of course, in a natural ventilated place, you're never going to achieve the ASHRAE standard. It's based on a certain amount of CFM per person.
Well, naturally ventilated classrooms often have exhaust fans.
Right.
Sometimes they're in the classroom, but they're so noisy that they're usually turned off. But, you know, at recess or overnight, you could run those in order to get some air changes. Sometimes they're a central negative pressure fan that's in the hallways or something like that. And so keeping the door open to the hallway, if that's the case, will allow more infiltration. And if you open the windows a crack or whatever, the air will come in.
Yeah. So there was one question that came up, John, about that I just remembered about that there's nothing in here about opening windows. What effect that would have?
Yeah, Pynchon did a study on that, and they came to the conclusion that open windows, especially when the temperature is extreme, will not do much. It will do something when the temperature is perfect. 10 degrees outside, 10 to 15 degrees outside is probably the perfect temperature for opening windows. But it's very dependent on, you know, where the wind's going, the shape of the building, what's around it, et cetera, et cetera. So it's very hard to quantify. In a naturally ventilated classroom, it will make a big difference. In a classroom that has an HVAC that's designed by ASHRAE standards, it probably won't make much of a difference.
Okay, Dorothy, I do want to just allow Ian to ask his question because we are over time, and we're happy to stay and answer questions, I think, John, but I just wanted to make sure that that Ian could ask, and then we can keep going.
Yeah, and Daryl had another question too, so if you could just add one to the list.
Okay.
Okay, can I just quickly ask my question? This didn't come up in the breakout room. It's the role of flushing classrooms in between occupancy. How does that add to the discussion? Is that something completely different? And is it recommended or required?
Sorry, I didn't quite catch the role.
Flushing or purging classrooms in between occupancy, and for how long it should be. I'm thinking of university classrooms now in particular.
Okay, yeah. Yeah, NIOSH has a table on that. You'll have to know the CFM in order to figure that out. And it depends on, you know, how clean you want them. I think their table is for 99% or 99.9%. And the difference, maybe, I don't know if Kevin or Masood can find it and put it into the chat box, but there are time schedules. Like I said, if you have, I guess you're in university, you don't have recess and lunch hour.
But they have 10-minute breaks between classes, or
Yeah.
they can change schedules, I suppose, if they had to.
Yeah, but it really, you have to know how many CFM and how much cleaning is going on before you can figure that out.
I think the question is it necessary at all? Does it help? Is it desirable?
Well, it may be necessary if you have poor ventilation. If you have good ventilation, it may not be necessary. It really depends on the room, the occupancy, the type of ventilation, et cetera, et cetera.
How much outside air is.
Yeah, there's no hard and fast rule. Every room has to be evaluated on its own. That was the idea behind this spreadsheet, is that you evaluate every room on its own.
Kevin,
There is some guidance from the World Health Network that I'm going to kind of be talking to this afternoon. But I'm just looking at my PowerPoint presentation now, and with their recommendation, they talk about assigning a COVID guardian to open windows for 10 minutes every hour. I don't know if that's helpful at all.
Yeah, World Health Organization or Switzerland or somebody like that talks about that 10 minutes an hour thing too, but I don't know the scientific basis of it. And it depends, as we know, with windows. If they're open across the hall and both doors are open, then if you get a cross draft, it's great. If you don't, it doesn't necessarily move that much air.
Okay, I just found it, so I'll paste it into the
Thanks,
but
John.
it's
Okay.
airborne contaminant removal, and it's based on air changes per hour, and it gives you the time required for removal of 99% efficiency or the time required for removal of 99.9% efficiency. So if you have 6 air changes per hour at 99%, it would take 46 minutes to clear out the room. But again, you have to know the air changes per hour. And these are air turnovers, not outdoor air changes per hour.
Thanks. Does that answer your question?
Yeah, thank you very much.
You
Thank
have
you.
a question?
Daryl had a question.
Thank you. So my issue is that, first of all, I'm a joint health and safety member. We have an office building setting, and the Joint Health and Safety Committee made recommendations to the employer, and the employer basically came back saying that they were not going to change anything and they were not going to cooperate with us. It was suggested that we get the Ministry of Labor involved, but our union staff rep advised us that that would not work because Ministry of Labor is now deferring to Public Health and the Medical Officer of Ontario. So I'm wondering how we can get this information regarding our facility about the HVAC. And that was it. I was basically wondering if anybody had any advice, any experience, any suggestions on how we could get that out of them.
Okay, well, I gave you 7 different ways of guessing or estimating or measuring the room ventilation rate. So there are 7 different ways there that you could fill in that number. I think the Ministry of Labor has not been especially helpful in dealing with ventilation, although they do have lots of orders for people to put their masks on. Another alternative way is that if you filled out this form and put it on every door in your building, that would probably prompt people who didn't like what it says on there to provide you with the correct information, and that might pressure them.
I like that. I like that. Thank you.
Also, the Health and Safety Committee has the right to information about health and safety, and therefore, I would think that it would well be within the rights of a Health and Safety Committee to ask about what the air turnover rate is in each room. It's, you know, if they have the ventilation drawings, they could easily pull those numbers off, and it wouldn't take much time or much effort. And since it's a health and safety issue, even if it's not COVID, COVID is a problem because the Ministry of Health. If you just do it from an indoor air quality perspective, you should be able to get those numbers for that reason. If COVID is exempt from health and safety.
So we have tried that.
I would then go to
half a dozen attempts, and we have been blocked every time. They provide us information which is vague and not helpful, and does not satisfy the requests of the Joint Health and Safety Committee. So
I was going to say that the ministry's enforcement of the COVID rules is maybe weaker than we would like, particularly with respect to Airborne, but they generally will enforce the structure of the Occupational Health and Safety Act. And one of the structure elements is the obligation to inform Joint Health and Safety Committees of any information in their possession about a space, and I think to respond to a legitimate request for information about your working environment. I think the ministry would support that. I would not discourage you from trying that.
Well, I continue to try, but we're stymied at every avenue that we attempt. We've managed to get them to, with a lot of pressure, and we actually had to submit a recommendation. They released a partial report. It's not certified or signed by anyone, but it seems to indicate somewhat some of the HVAC status of the building. So that's why I was wondering how I could. I do like the idea of what you said about posting on every door the ventilation of the individual rooms, which would probably prompt them to respond.
And the other thing,
could I suggest, you know, it does actually come back down to the internal responsibility system. If you think about regulations, they're a minimum standard. So, you know, we can go above that, and the internal responsibility system is kind of provides the rationale behind that. So I just thought I'd throw that in too.
Yeah, it's a puzzle. Other occupants of the building would be the other thing I might try. Talk to your neighbors, because we've had some success in that. Even in looking for real estate for our office, I phoned and talked to the main occupants of our building and asked them questions about ventilation and that kind of thing, because they may have more proactive health and safety ability. You know, wait, that didn't sound right. I don't mean they have more than you, but you know what I mean? They just may have a different work environment, and for whatever reasons, they may have the mechanical information. So that's another avenue to try. I see that Murray has his hand up. Murray, did you have something you want to report about your group?
Yeah, there was a question about equipment, and you know, this is capital expenditure in organizations like ours in OCal that's a kind of an issue. And however, if you don't have a lot of money and you're looking for equipment that produces a result that you can take to discussion with the organization or the company or whoever it is you're trying to persuade. Can you get reasonably priced equipment that is good, produces good results? Now I looked at the Aeronet. I thought it was under $100, but I see the cost is somewhere around 300.
Yeah, 300 for the personal one. I haven't looked in the States. It might be cheaper if, not that any of us want to drive over there right now, I guess, and pick something up, but it might be cheaper if you have a US place to buy. It's 300 for the personal one, or 325 actually from the place in Cambridge, Prescient, I think it's called. And then there's a pro one for 369. But sorry, I didn't mean to interrupt you, Murray. There is another one show that's cheaper, that's more like a walkie-talkie looking.
So this one, I think said you had difficulty actually downloading the information from that, but it worked in the end.
I'm thinking about getting the pro version for us anyway, so it would have more capacity, more capability.
But for someone with less money than OCal,
yeah,
would it be better for them to try and rent rather than purchase?
There's talk in Toronto about libraries buying them and lending them, but I don't know if that's actually happened or if people can influence that in their local area. Talk to a library about, because they're kind of in the business of lending things.
Sure, there's a tool rental places too that might work. So I don't think we're there yet. I think I think maybe in the future things will be more available, but right now the equipment is fairly expensive. I don't know if there's a cheap velometer. Has anyone seen a velometer that's
it's in the garage,
other than the garbage bag?
I was just going to say the garbage bag and the stopwatch work pretty good.
Well, actually, as I pointed out to you, if you just videotape it, you can use the timing marker on the videotape, right? So you don't necessarily have to have a stopwatch too. You can figure the time out later, potentially. Sorry, and Murray, I didn't mean to.
But that's a difficult one to argue with the company. For instance, you can say, "Oh, my garbage bag reading is such and such," and may lack some credibility. You have to have a very
well. It may put the onus on them. Like I suggested to Daryl, if everybody posts this up based on numbers that the employer thinks are unreliable, well, then the onus is on the employer to provide the equipment and the expertise to provide the proper numbers. It's a start. It puts pressure on the parties to do better.
So could a school board or a teachers union purchase some equipment and share it?
Yeah.
I think many of them have. Most school boards that I know of have a carbon dioxide meter, and often it's one that's a few $1,000s, a much more professional and accurate one than the ones that are being bought online.
Mm-hmm.
So they're probably there already, and I know of some unions that have bought them also.
We have some people from health and safety at school boards and universities. Does anybody been implementing carbon dioxide monitoring as an indicator at all yet? Or even checking the computer? No. I see, Kevin, you have a question, but Murray, was there anything else then, or?
I think that was it, really.
Murray, I saw another item about how long to measure the CO2 that you were in the process.
Oh, yeah. Yeah, that was sort of cut off at the end. And I guess what I was trying to say is it just depends on what your instrument is. I know we had this discussion years ago, John, whether to get a powered instrument that would that was powered so that you could walk around and get readings as you walked, versus a passive one that doesn't have air flowing through it. And the passive ones, you have to sort of sit there and wait to get a reading. So it's
it helps if you wave the wand around. It does. Because what you're doing is you're passing more air over the sensor. What Murray's saying is that some expensive models actually have a little fan in that blows the air from the room over the sensor, so it equilibrates with the environment much quicker than the ones that are passive. And obviously the cheap ones that we buy on, well, relatively cheap, the $400 ones, don't have a little fan in them, and they need time to equilibrate. So if you walk from one classroom to another, if you walk too quickly from one to another, you're actually still measuring the carbon dioxide in the room that you left when you're in the next room. So yeah, that's an important factor to keep in mind.
Plus your breath when you carry it. I think it repeats every minute, I think, or write it. You can probably program that on the AirNet. But you do, Kevin's going to talk about that this afternoon too, about not being...
Yeah, I just wanted to share with this audience too, like just to go on what Murray was saying, it really depends what you want to do. Like, do you want an indicator up on the wall, or do you want to do real-time monitoring? And I think there's a lot of work that needs to be done around that area. So it's just a very general question. So I just wanted to share, and I'm not getting any money from this, but AeroNet did send me an email, and they do have a special on at the moment. And you know, I see online the AeroNet Home one it's out of stock, but they're offering a special on the Pro at the moment. So they're offering a special with the Pro at $269, and the thing with the Pro, it can connect to a base station in case you have multiple sensors to manage. So if anybody wants to find out a bit more about that, they could contact AeroNet. And yeah, but the other thing I just wanted to mention is if you hold the AeroNet in front of you, you're breathing on it. And my colleague Todd from the Ottawa Clinic reminds me, rightly so, that it should really be more than 2 meters away from you, not to be affected by your own breath as well. So that's that.
Which as we said, is difficult in an airplane, but when everybody's so close together, right? So okay. I see Mary Campbell's commented that they were successful getting 24-hour CO2 monitoring in certain rooms at MAC, which is great, but of course takes a lot of dialogue, I'm sure, at the Health and Safety Committee and elsewhere. And I do know, having worked in university environment before, that indoor air quality can be a big concern, and that there definitely are pockets that are just underserved by virtue of giant HVAC systems that have been renovations and who knows where the ducts went and where the return is and all that. So I think, and then Dorothy, you'd also mentioned the ways to tell if a diffuser is working, which doesn't give us a measurement, but actually gives some indication of air coming in, air movement in the space, which is helpful to know whether there's more to look for. Did anybody else have any other?
Can I just throw in something else that came out of our group discussion? And I'm really grateful to Tracy Edwards to help guide it, because and she was helping with the discussion too. But something that came out, an interesting comment, was this whole notion around mixing in a room. Unequal mixing, not uniform mixing, which is a really important thing to think about, with the barriers, perspex barriers and that. And, they were sort of talking about, well, could the tool kind of be modified to consider unequal mixing? And it's not really designed for that. It's really just more empirical to look at air changes per hour. I don't know if you had any comments on that, John.
Yeah, we had someone who also asked about mixing. And the short answer is, for a classroom, which doesn't have barriers. I don't think the mixing factor is that important because the air is usually spread quite widely. You've got a lot of occupants in the room who are moving around a fair bit. So mixing is not that big a deal there. It would be a bigger deal in offices and maybe in meeting rooms and things like that. I did talk about there is a thing that you could add to the equation, which would be mixing factor. And what we could do is add an extra box in there, and then a drop-down box saying, good mixing, poor, medium mixing, poor mixing, and then that would allow you to adjust the HVAC flow rate by correcting it for poor mixing.
And this is going to be a super fantastic tool, every idea we get, right? But it's, I guess, is there an equation that uses mixing factors that you can build on from ASHRAE or wherever? Great.
Well, basically, you multiply the flow rate by the mixing factor.
Makes sense.
If you're not using, let's say you have 1,000 CFM, but if let's say 200 of those CFM are being shortchanged or short-circuited because the return is right beside the diffuser, then you have a 80% ventilation effectiveness factor, and so you multiply the 1,000 times 0.8 and you get 800 CFM, and you use that instead of the 1,000.
That's useful to know. Okay, I think we need to wrap up. Those who have stuck with us, we really appreciate it, and we welcome your questions. We do have an inquiry service at OCOW that you can just email ask@ocow.on.ca if you have any other questions, or find us. Our emails and contact information are on the OCOW website. And we will be back in only an hour or 59 minutes for the webinar this afternoon with Ryan Imgrund talking about the latest numbers and patterns of where things are going. Kevin talking about CO2 and other tools in the toolbox, and David Elfstrom talking about ventilation, filtration, and UV, and then some more about how to better fit respirators and the critical importance of that, particularly given the high transmissibility of the Omicron virus that we're facing coming down the road. So, and not so far down the road with the outbreak in London. So anyways, I think we will close it off for now. But once again, thanks to the facilitators, Murray and Kevin and Dorothy and Masood, and especially to John for your presentation and for the ongoing work on the tool to bring health and safety into the hands of workers and workplaces to solve problems together. So thanks very much, everybody, and maybe we'll see some of you in an hour. Bye-bye. John, did you have anything to say at the end?
Thank you for hanging in there, and good luck.
Yeah.
Call us if you need help.
Yeah, exactly. Thanks, everybody. Bye-bye.